Hi, I'm Pratush, and I'm a civil engineering major.
Hi, I'm Kubal, and I'm an aerospace and mechanical engineering major.
Hi, I'm Will, and I'm also an aerospace engineering major.
Hi, I'm Timothy, and I'm an electrical engineering major.
And this is our presentation on HydroCanopy, a way to protect almonds. And first of all, Pratt will begin by discussing the problem.
Okay, so to give a little background, California agriculture, especially the almond industry, is vital to the national as well as the international food supply and economy. California produces around 80% of all almonds across the world and almost all almonds in the nation. A world without almonds might seem insignificant at first. However, this industry produces around $11 billion in revenue annually in California, making it one of the backbones of California economy. So, to summarize, the success of the production of almonds not only affects the national and California economy, but also almond farmers' way of life, and furthermore, the environment because of the use of water. And Kubal will talk in more detail in the next slide.
So why is this almond industry at stake? As can be seen over the past few years, the droughts plaguing California have been straining the water supply of many farmlands. In 2018, 61% of water is solely used for agricultural purposes, greatly impacting the yields produced. Even in the past few months, we've seen a decrease in yield, even through the many wet years that we've been having, because the farmlands are getting flooded, decreasing the productivity of pollinators. To solve this issue, we wanted to create a product that can tackle these problems. First of all, we wanted to make it affordable to farmers, make it for every individual farmer so that every farm can benefit increasing yield. We wanted to be able to conserve water as well as protecting soil moisture evaporations so that even irrigation water can be stored easily. And finally, we wanted to make it easy to use by any farmer as it has to have the greatest function possible. Now, will discuss on the prototype itself.
All right, so here's a picture of our very first prototype, and here's a model of our motor. And our solution is basically a sagging tarp suspended by a frame over the almonds. We have a motor connected to a pulley system that can extend or retract the tarp. We also included a photoresistor to collect data on the light level, and once we've determined that the almonds have gotten enough sunlight, we can extend the tarp to preserve moisture in the soil. The tarp can also be extended manually so that when it's raining, the water can collect there and funnel through a hole in the center of the tarp. This also functions to protect the almonds from flooding. Our tarp material is made of two layers. One is a plastic clear layer that is waterproof and will help us collect water. And the second is a shade cloth layer that shades the plants while still letting in some sunlight and keeps the soil moist. Tim will now talk about our future steps.
So, for our testing, we want to test how durable the prototype can be in practice when facing wildlife or long-term weather conditions. We also want to test the prototype directly on an almond tree farm to see if it accomplishes what we initially have strived for. Then we also want to test the total amount of water that can be collected from the farm and the prototype during a rainy season, and the overall total energy use and efficiency of the entire system itself. In the future, we want to receive farmer feedback and criticism from our designs to help us continue and develop more prototypes off of that criticism. And that's our prototype. Thank you for listening and watching.